questions too.
So planning from the problem section, it'll be either a mode, trip distribution or a route choice problem. And then questions.
Like the 5 steps or whatever.
4 steps for planning. I think it's 5 steps for data collection. Okay. What came after that?
Bunch of CAD.
Bunch of CAD stuff. Yeah, we'll have. We'll do ArcGIS and CAD questions. I don't think we'll do a take home. I think that seems reasonable. Like I've already tested you as much as I need to test you on those 2 things, right? We could probably do something for CAD, but I'm good with it. If you got an A on the midterm, on the first midterm CAD thing, I'm pretty comfortable where you are in CAD. Like you go into senior design and you'll be appropriately situated for what you need to do. You could do all the CAD drawings you need to do if that was your level. Okay, what was X? Barking. So parking will have probably a problem like that.
The same.
Yeah, because I just gave you the raw input, and then you pretty much tell me how many cars are in there and how many minutes those cars were there for, and then do the math. We never really did a lab for tube counting, right? The reason is because I couldn't get IT to upload the softwares that I needed to make it accessible to you guys. They weren't going to upload it to their server, and putting it on this computer and one computer in the lab wasn't really going to make it anything that was going to be usable to have 20 people in there. So I will ask you two questions. I guess I don't know, keep with them.
Can you upload that PowerPoint or that like text page or whatever the tubes?
Over. Thanks, cool.
Or whatever, something for the tubes.
You showed some file in there.
Some kind of visual aid.
It described the 2 ways of setting up the tube counters.
The thing with the, yeah, okay.
There's an assignment called 2 counters due the 29th, and then are we supposed to ignore that?
Yeah, I'll do it.
Okay.
These are clearly notes for me. So I'm gonna take a picture of this when I'm done and make sure when I make the exam I kind of stick to it. At some point we said there were 5 steps to data collection. What are those 5 steps?
Let's see. Identifying, this is for parking study.
Okay, yeah,
Identify when and where,
yeah, so we'll go.
so when.
Yep,
Step 2 is how. Step 3 was field visit. 4 was data collection. And then 5 is data processing.
solid 5-point question on the test. So it's how to collect, where, when to collect, then how to collect, the field visit, the data collection, then processing. Okay? Tate, you'd say it's pretty accurate? That's what we do in the office? Yeah, I mean, the how you collect is dependent on the where and when you collect. Then you have to go out there and like see if how you think it's going to work is actually going to work. And you just go collect it, and then you have to do something with it to make sense out of it, generally. Unless the goal is just getting like the number of cars or something. You still have to present the data somewhere, whether it's a table or a graph or something. All right. What else did we do? What did we do last week? Killing me, Smalls. I guess we had the exam last week, yeah.
We had an exam and then we did the GPS track thing.
Oh, yeah. Okay. Problem. Total delay and stop delay, and questions. Okay. All right. Let's talk a little bit about that. What are some questions I could ask for that? Yes, sir.
I mean, would you give us a graph and then have us look at the little segments?
You can probably bet that's on the exam, yeah. To calculate the total delay and stop delay. What's that?
What's platooning?
Yeah, platooning is a good one. Why do platoons break up?
Speedsters.
Yeah. People have different desired speeds. So then, some people want to go faster, some people want to go slower. So they kind of split up over time, and then you kind of like platoon them up again. Why is platooning beneficial?
Better control where the traffic goes. No.
Why do we want cars moving in tight pods?
It helps you with your goal of moving that one group through a system.
It's easier to move one group of cars together through the system.
Movement of people and goods efficiently.
Yes. Pods safer? Probably not. But they're efficient, so pods are good. Okay, what, other than the natural influx of people, what, as far as the traffic conditions, can break up your pods?
Pedestrians.
Pedestrians really mess up pods. They can, if they're not incorporated into the signal, right? If you don't expect a high pedestrian, then if you're not anticipating that, if you're not planning for that, then it's an issue. What else? A bunch of driveways, a bunch of people turning on that weren't in the platoon, slowing down the platoon. Like if you turn out in front of me and now I gotta wait for you to accelerate, that'll mess up the platoon. Pretty much anything that causes you to change or reduce your speed has a potential to mess up your platoon, or anything that causes changes to the signal itself. Emergency vehicles, that can really destroy a platoon. It can also, if it has preemption, impact your signal. Yeah, anything that really kind of messes with your speed, right? If this light turns green, and then 20 seconds later the next light turns green, what is that called? It's called an offset. We talked about this. This one turns green, then 20 seconds later this one turns green, right? Now when you have a bunch of those, it's a green progression. We won't really I won't ask you green progression, but offset is something I want you to know that we talked about. When you guys are in your master's program and you take advanced signal control, we'll talk about this more. Tuning, offsets. That's pretty good. Total delay, stop delay. All right. What if I gave you the time-space diagram and told you the free flow speed?
You did plot it.
I didn't plot it. Ooh.
That's the map.
Is it?
Is it really? You just take
Is it really? It's a constant speed.
1.47 and then you'll take the relative positions.
I don't even know what you're trying to refer to.
You'll take the speed, multiply by 1.47, put it into feet per second, and then use that as your slope to graph off the relative axis.
Yeah. And if I told you the free flow speed was 36 miles per hour. Okay. In 1 second, how fast would you go? $36 times 1.47 is?
Like 50 feet.
Oh, it's not making it. And the next one would be. And you would go. Like that. Right.
1.47 for that number.
Total delay would be. Delta 1, Delta 2, Delta 3 for stop sections. Yeah. Okay. What causes the difference between the total delay and the sum of the stop delays?
Like acceleration time?
Acceleration, deceleration. Also interruptions to the free flow condition. Queuing will do it as well. Anything that is not stopping the vehicle, but is like a rolling delay, right? Seem reasonable? Okay. Okay. What else? Did I miss it? Yeah.
Are you gonna bring back any of the TMC question?
I may pepper a couple of those in there.
Okay.
Nah, I don't think so. You guys memorized them already once. I mean, they were pretty straightforward. I think everyone got all those right. So.
What did you say the formula chart that we can bring is? Sideline?
6x4,
Oh, sorry.
one side. What else? All right. Any questions that you want me to go over or answer? All right.
Could you flip that thing?
Yeah.
back?
All right. What do we think of the class now that the lecturing is over?
I like the format, like we would do, like, some theory stuff, we were actual problems that we actually do on homework and stuff. And then we would do like a practical application and feel like reinforce that.
All right.
It was nice to actually finally learn AutoCAD and ArcGIS.
I mean, I didn't do a whole lot of teaching on it. I made you guys learn it, which is learn through discovery. I can't.
All the job.
I'm giving you the incentive to figure it out on your own, right? Give you some of the tools here, and then you guys just got to go slam your head against the wall for a little bit and figure it out. Yes.
I think you need to make like 2 more sets of slides. You don't have to be crazy, but
Something for you guys to look back on and review.
yeah.
All right, more slides.
And maybe consider a rubric for the CAD and GIS assignments. Because us learning by ourselves is great, but like, what if we have nothing to gauge what we're expected on?
All right, rubrics. All right. I tried to make this class hands-on, where the last one was heavy in theory, 0 hands-on really. So this class is kind of a counter to that class. Ideally, I would probably break up the 2 classes and have them interwoven, where we would start with a series of lectures, do a lab, series of lectures, do a lab, series of lectures, do a lab. But I don't get to control over that. There's certain, like, a lot of you may only take 311, and therefore I gotta cover everything that's gonna be on the FE in 311. So it's heavy on theory, man. This class for me is a lot more fun. I like being outside. I would much rather lecture outside than I would indoors. It kind of lets me share some of the things that I get to do with you guys. It kind of sets the foundation for when you guys go into a master's program and the things that you're going to be doing. Not necessarily like, not tube counters, but sometimes, yeah, tube counters. You know, I would have liked to have gotten to more modeling and stuff, but really the only people that are going to be modeling are going to be the real traffic people. I guess this is like an elective class, but you have to take it. You could have taken a different one, I guess, but you know, that's kind of heavy stuff. And if this room had computers in front of us, I would have done the modeling, I think. But to set it up and make you guys try to go find a computer on campus when it's not on the server thing, I think that would have been too much. I think we were kind of limited with this classroom. I mean, I had to cancel 2 classes because I couldn't get the projector to work one day. Yeah. But, all right, rubrics, more labs. I probably won't teach this class again for like another 2 years. I think this is Dr. Chen's class. This is a class that she enjoys teaching. You know, I've never taken a class with Dr. Chen, but I imagine she's more organized than I am. I don't know. That means that none of you guys have ever had Dr. Chen, yeah? Who's had Dr. Chen in class? What was it, like statics or something? How was that?
It was good. I like it better than static.
You like solids better than statics? So, my program, when I was an undergraduate, we had an older Indian gentleman named Dr. Rakasamy. And he taught solids, he taught concrete, he taught steel. I had somebody else for statics and structures, but, oh, and he taught materials. So, like, he was, and he spoke in a very monotone Indian accent. Very nice man, very smart. He could freehand a circle that was almost perfect. Freehand a straight line that was parallel and straight. I think he's still teaching at FAU. We one time made him a brick for the materials class. We had to carry it back to his office for him. It was so heavy. Yeah, very nice man. But his idea of a PowerPoint, he scanned pictures of the book, highlighted sections, and then read them.
Sounds familiar.
It's old school.
He's very old school. Very. Yep. And he finished every lecture with a picture of flowers. Like beautiful exotic flowers.
Like Phalaenopsis.
Oh, I have no idea. Yeah. I tried doing that for one class. I was going to finish every lecture with a picture of Emma. I got through like 4. So, that's when she was like this big. Now she's huge. Okay. Any questions? Yes, sir.
Could you just maybe give an example of what a tube question would be?
Okay. How would you identify vehicle classification from tube?
Distance between the axles,
Okay, how do you get distance between the axles?
time difference, and speed between the burst of air.
Right, from the first tube and the second. So you have 2 tubes. Alright, here to here gives you the speed. The time between here and the second here then gives you the distance. Distance between the axles fits into a certain bin, and that then counts towards whatever. Alright? So you need 2 tubes, one to get the speed and the other one to get the time difference between the 2 hits. And then knowing the speed and the time between the 2 hits, you can predict what the vehicle class is. Also, by predicting what the vehicle class is, you can predict how many hits you're going to get and know to ignore those when counting for the next vehicle. Okay. What's another typical data collection for counters?
Just volume.
Well, yeah, okay, so another question would be, what does it collect? It collects volume, speed, vehicle classification.
Occupancy, right?
It doesn't collect occupancy. What collects occupancy? Magnetic loop detectors, right? Those are the ones that are kind of embedded in the roadway, embedded magnetic loop detectors. It calculates the magnetic flux as the vehicle. It works the same as this, except they're embedded in the ground. And it can also calculate the occupancy, which is the duration of time at which the detector is covered. And from there, it can back calculate out the percentage of time it's covered. Percentage of time it's covered, it can calculate the density. So, know what a magnetic loop detector is. Solid question. What's another way we can calculate the number and speed of vehicles?
Imagery.
Cameras. Yeah. Alright, so the cameras are looking for color changes within individual, I say boxes, but they're really not boxes, they're like little points on the screen.
Pixels.
Pixels, yeah. When the pixels change within a certain grid, it knows that there's a vehicle present, or pedestrian, or bicycle. Yeah, these aren't really good for collecting bicycles or pedestrians, and neither are magnetic loop detectors. Video imagery is, because you kind of know where they're supposed to be. So you can set up a box there. So, What else? Yes.
Like ArcGIS and CAD questions would just be like, what is this thing? What is this thing?
How would you do this? How would you do that? I'm not gonna ask you something you didn't already do.
Okay.
We want to make sure you did the lab. And there you go. Maybe I'll ask you how to do something, and you'll give me a couple steps. And that something will be something I asked you either on the test, or something that you did for the exam, or something that you did for the lab. Nothing crazy. If you did both of those independently, you should be fine. Because you banged your head against it for 20 minutes, this is me giving you an opportunity to get credit for the time you put in for that. Is my eye distracting?
No, I was thinking the Latin translation for I learned through suffering could be translated as Disco Inferno.
Thank you, John. I don't think there's ever been a more well-read student crossing through these doors. Yes?
Would parking questions be on like data collection, or would they extend
No, that would be
past
different.
that?
Yeah, I don't really know parking questions. I haven't really thought about parking questions yet.
Okay. Scratch them.
Fine. Make you feel better. Good, Daniel. Or good evening, Harper.
Hey, no one else is gonna ask questions.
If you went online and looked at the videos, you should thank Daniel because he did all that. I had nothing to do with it. Thank you, Daniel. Anything else?
And just finish it off. What's a planning question like?
What's the 4-step model?
Okay.
Here is an origin destination matrix. Here's a calibrated origin destination matrix. Fill in the blanks.
The little.
What's that?
The first stage of test one.
Okay.
You're describing the first stage of test one.
Yeah.
Class reference.
Something like that. You know, that PowerPoint. What else? Is that it? Everyone have a good semester? Better than last semester.
You're the best class to have from 8 to 2.
Okay, I'll take that as a compliment. I'll take that as a compliment. You can thank a jar for making this at 8:15. I just told him that I wanted to be in person. And he had to go find me the rooms. He said, well, I got one for you, but it's at 8:15. I'm like, done. In person, man. No Alpha Bravo and all that. Is any of your classes Alpha Bravo shift or whatever they call it, split mode?
Yeah.
Yeah. Gadrar worked hard to make that happen.
Gadrar did a really good job.
Almost the class has always been in person.
Yeah.
Except for air pollution last semester.
There's no way I could have done Sue's concrete class.
Yeah. A lot of students, the rumor was a lot of students struggled with Dr. Madeiro's class in split mode too.
Oh, yeah.
Yeah. So,
Medeiros did a pretty good job, all things considered, because he was teaching hydrology for like the first time last semester, and so that plus a split class plus Medeiros, it was.
plus Madeiro's.
No, he's a good guy. He's just really squared away. You've got to like be on board from the get-go. You can't just come in 50 minutes. Respect it.
All right, guys, it's clear that I'm starting to lose you. So, that happens, yeah. I mean, all right, so I'm going to stick around and answer any questions you have. If you want to talk about your grades, or you want to talk about exams, or you want to talk about lab stuff, I'll be here. You can think of this as like open office hours for the next 40 minutes.
This is your last time on video. Any goodbye message?
Peace.
Okay.